Hey guys, and welcome back to another A-Level Maths revision video. And in this video today we're going to take a look at some second year applied material. And we're taking a look at the stats part, we're taking a look at probability. So the second year material for probability is basically just a continuation from what you learned in the first year, but now we're including what's called conditional probability. So like you can see here from this question, I'm not involving any question which involve tree diagrams, probability trees, anything like that, or Venn diagrams as such. I already featured quite a lot of them in the first year material, and as such I feel like it's just kind of extra on top of that. So I've just focused on questions which involve solely probability. Okay, so 3 questions, let's just jump straight into them. So if I get the right pen colour here, this is from Edexcel's S1 paper. This was the old spec, Jan 2012. So question 2 here, we start with this part A, which is more of just kind of a wordy question. And we're asked to state in words the relationship between two events, R and S. And then we're given this probability here, so you need to kind of know what this little bit of notation here means. In the middle, okay, this little bridge sign like that, I need to know how to read a probability. So hopefully you can read a probability. That should hopefully be straightforward enough, but you might not have come across this notation before. So this little kind of bridge, I call it an N, it just means intersection. So this is the probability of R and S. Okay, and we're saying the probability of R and S is equal to 0. So the probability of R and S occurring is equal to 0. What that tells us then is these two events must be mutually exclusive. Okay, so R and S are mutually exclusive. Okay, basically they can't occur at the same time. Okay, so that's all we need to say there for part A. Like you see, only 1 mark, we don't need too much for it. So now let's jump into the more mathematical questions, or parts, should we say, part B here. So we're given 2 events which we're told they're independent, so that will be important after. We've got the probability of A occurring is 1/4, and the probability of A union B, so this little U here, okay, that means the union, so that's A or B, and that's 2/3. And we're asked to find the probability of B. So how would we do this? Well, the first thing I'm going to do here is make use of the fact that we know A and B are independent. So if 2 events are independent, okay, so if they're independent, then what we can say is the probability of A times the probability of B is equal to the probability of A intersection B. Okay, now this is only if 2 events are independent, so that's why we've been told that, so we're going to use this fact. And remember from your formula book, so we can use this from our formula book, the probability of A intersection B, so A and B as I call it, that's equal to the probability of A, so the probability of A plus the probability of B minus the probability of A union B. Okay, so we could rewrite this here. So the probability of A times the probability of B is equal then to replacing this probability here of A intersection B with this part. Okay, so we can write that as probability of A plus probability of B minus the union. Okay, so A union B. Okay, so what does that tell us? Well, we know the probability of A already, that's 1/4. We know the probability of A union B is 2/3. Okay, so we can start putting everything together here. So the probability of A is 1/4. So what I'm going to do here now is 1/4, so 1/4, times the probability of B, which we don't know, so we're just going to call that probability of B. Okay, so basically this is probability of B divided by 4. It's going to be equal now to the probability of A, which is 1/4, plus probability of B, which we don't know yet, that's what we're looking to find here, plus probability of B, minus the probability of A union B, which we know is 2/3, so that's minus 2/3. Okay, so I've somehow run out of room already. The questions are quite large, so if we finish it up here, okay, so I'm taking this line here up to the top. What we need to do now is just evaluate the probability of B. Okay, so this is just a nice straightforward equation. Just use your calculator or do it by hand if you find that easy enough. So what I'm going to do here is minus 1/4 of probability of B here from both sides. So what I get in that case then is 3/4. So I'm going to do 3 lots of the probability of B over 4. Okay, so taking this 1/4 of the probability of B onto this side, and then if I do 1 over 4 minus 2 over 3, and I'm going to take that over to this side. So basically I'm taking this to this side, and then this and this onto this side. Oh no, we're going to the wrong page. Try again. There we go. Okay, so that's going onto that side. Okay, and if we evaluate that up here, what we get then is 5 over 12. Okay, so hopefully that step makes sense. It's kind of difficult to see as I'm going from the bottom of the screen to the top, but all I've done here is just simplified and collected the like terms. And all you're simply doing here now is just solving this nice straightforward equation in terms of the probability of B. So I'm going to times by 4 and then divide by 3. Okay, so I get 3 lots. Probability of B is equal to 20 over 12, and then we divide by 3. So we get the probability of B is equal to 20, and then we just times the denominator by 3 here. So I get 20 over 36. Okay, so 20 over 36 there gives us our probability of B. Obviously, a few quick little checks you can do here is make sure your probability is between 0 and 1. You get a value bigger than 1, something's gone wrong. Smaller than 0, again, something's gone wrong there. Okay, so always, bit of common sense basically. Just make sure your answer seems sensible. So that's part B there and part A. So let's just clear everything now, just so we've got enough room for part C and part D. So for part C here, we have to find the probability of A complement intersection B. Okay. So this comes down to the fact now that we know A and B are independent. Okay. Remember, if A and B are independent, then what we said was the probability of A times the probability of B is equal to the probability of A intersection B. And this is true with the complement involved here, like this. Okay, so the probability of A complement intersection B, well, that's just the same as doing the probability of A complement times the probability of B. Okay, so that's also true. And again, that just refers back to the fact that A and B are independent. So all we need to simply do here is evaluate the probability of A complement, which is simply going to be the probability of A complement. Remember, that's just going to be 1 minus the probability of A. So if the probability of A is 1/4, this is 1 minus 1/4, giving us 3/4 there. Okay, so all I'm simply doing here is 3/4 times by the probability of B. And the probability of B we just worked out was 20 over 36, or if you simplify that, 5 over 9. Okay, so that's 5 over 9 there. All we need to do now is evaluate this product here. So 3 over 4 times 5 over 9, which gives us 15. That gives us 15 over 36, which we can simplify to 5 over 12. Okay, so just give me a moment, my mic is dropping. So we get 5 over 12 there. Okay, so hopefully that one isn't too bad. So that's part C. And then finally part D here. Just finish up here with part D. This is now where we have a bit of conditional probability. So we're looking for the probability of B complement given A. So this little line, that just tells us that A has already occurred. Okay, so it's given A. And there's a formula for this in your formula book for conditional probability. So remember, if you're looking for the probability of A given B, this is equal to the probability of A intersection B all over the probability of B. So we just need to apply that now for our given probability here. So the probability of B complement given A is equal to the probability of B complement intersection A all over the probability of A there. Okay? And again, we can just refer back to the fact that A and B are independent. So this top probability here, this intersection, this will simply be the probability of B complement times the probability of A, and we divide this by the probability of A. And clearly here, if we do the probability of B complement times the probability of A, and then we divide by the probability of A, these will just simply cancel cancel. And all we're going to get left with here is the probability of B complement. And this is now rather straightforward. To work out the probability of B complement, we just do what we did here for A complements. It's going to be 1 minus the probability of B. And in that case then, this is 1 minus 5 over 9, simply giving us 4 over 9 there. Okay, so the probability of B complement here is 4 over 9. So the probability of B complement given A is just 4 over 9. Okay, and that gets us our final 2 marks there. So quite a long question, longer than we're expecting, but hopefully not too bad. Okay, so let's move on to the second question here. This question, I think, looks a little bit different because you're given some values in the form of a table, but honestly it's not too bad. So what I'm going to do here just for this one is change to a black pen just so I can kind of draw around this table. And what this is looking at is 200 employees which are classed as either full-time, part-time or contractors. Okay, and we're told their method of transport. So F, H and C, so F represents a full-time worker, so we'll put the F next to that. The H represents a part-time worker, so we'll put the H there, and then clearly C represents the contractor. So we're going to let W be the event that an employee walks to work. Okay, so just so we're aware of that for B and C. So we start with part A here, the probability of H. What we're looking for here then is the probability that we have a part-time worker. Remember, H here represents part-time workers. So the probability of being a part-time worker, well, we use the table here, so we're looking across this row. So we've got 2 values here. We've got this 35 and this 75. So what I'm doing here is adding these 2 values. So the probability of being a part-time worker will be 35 plus 75. And now we're going to divide this by the total sample here, okay, which is 200 employees. So we divide that by 200, and clearly 35 plus 75 just gives us 110. Okay, so I get 110 over 200. Okay, and you could clearly express that as a decimal if you wanted. It'd be 11 over 20, giving you 0.55. That's absolutely fine as well. But for now, I'm just going to keep all these as a fraction. Okay, so for our first one here, the probability of being a part-time worker, that's our solution there. Now, part B looks, I think, rather complicated, but it's honestly not too bad. What we're looking for here is the probability of F intersection W, but we want the complement of that. Okay, so F intersection W is a full-time worker who walks, but we want everything other than them. Okay, so how do we find that? Well, what I'm looking for here first is the probability of being F intersection W, so being a full-time worker who walks. Well, in that case, that would simply be looking across this row and then matching it with walk. So that's just going to be this 2 here. So that would give me 2 over 200. Okay, but we want the complement of that, so that's everything other than this event here, 2 over 200. So to find this now, this solution here for the complement, we do 1 minus 2 over 200. Okay, and this would clearly be 200 over 200 minus 2 over 200. So that would give me 198 over 200 there. Okay, so hope that one doesn't seem too bad there. All we've done first is just found F intersection W, and then found the complement from that. Okay, so that's our solution there, 198 over 200. And again, you can give that as a decimal if you prefer. And finally, we're looking for the probability of W, so they walk, given they're a contractor. Okay, so this one's just a little bit different. We have to be careful, and this is where the conditional probability comes in here. So if we're looking for basically a contractor who walks, we're only considering values now from the contractors. So our total sample here, in effect, is going to be 30 plus 50. So what we're going to do here is divide this by 80. Okay, so it's not 200 here, be very careful, but rather out of 80. So that's what that conditional part tells us. Okay, so that's how many we're doing in total, so that's where the 80 comes from. And then for the W, we're looking for how many people walk who are contractors. And clearly, that's going to be 30. So it gives us 30 over 80, which again you could simplify to 3 over 8, or give that as an equivalent decimal if you prefer. Okay, but this is what you should get here for part C. Okay, so 30 over 80. And then finally, let's move on to the last question here. And this one is from S1, Jan 2013. And we're given a few different probabilities here. We're given the probability of A, the probability of B, and the probability of A intersection B. And the first part here, we're asked to find the probability of A union B. So if I just change back to my original pen colour here. So A, we're looking for the probability of A union B. So how would we do this? Well, in this case, we just go back to our formula book, and we know from our formula book the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. And we've already been given all of this information, so this is rather straightforward. The probability of A is 0.35, probability of B is 0.45, and the probability of A intersection B is 0.13. So we minus 0.13 here. And if we evaluate this, well, 0.35 plus 0.45 gives us 0.8, minus the 0.13 gives us 0.67 there. Okay, so that's simply all we need to do for part A. Now for part B, you can do it without a Venn diagram, and that's absolutely fine. I think drawing a Venn diagram here just to see what's actually happening, you don't need to use it to actually answer the question, but just so you can see what's happening does make it a little bit easier. So before we draw it, let's just take a look at what this probability is looking for. So we're looking for the probability of A complement given B complement. So here, first let's use our formula that we know. So in this case, using our formula book, we can write this as the probability of A complement intersection B complement. And we divide this now by the second one here, what we're given by, probability of B complement. Okay. So if we just think about our Venn diagram here then, again, doesn't need to be perfect or anything, just so we can see what's actually happening. So this is A and this is B. Well, we're looking for the probability of A complement and B complement, okay, the intersection. Now, the probability of A union B is everything in these circles, okay, that's the probability of A union B. Now, the probability of A complement intersection B complement is everything outside those circles, okay? What's not A and not B. So that's everything outside here, okay, outside the circles. And that's what we're looking for. And that's the complement of, so we write this out here, probability of A complement section B complement. This is equal to, basically like we just said, the probability, or the complement, the probability of A union B, okay? Which we already know, we just worked out in part A. So these questions go quite nicely together. So in that case then, we can just write that here. So it's the probability of the complement of A union B. And we're going to divide this by the probability of B complement. We can easily work out the probability of B complement. And the probability of A union B, and then the complement of that, well, that's simply going to be 1 minus this value here. Okay, so it's going to be 1 minus 0.67, giving us 0.33. So that's our numerator here. And we divide this by the probability of B complement. So B complement is 1 minus the probability of B. So 1 minus 0.45 gives us 0.55. All we need to do here is plug this into our calculator, and what we get is 0.6 there. Okay. And then finally we move on to the very final part of this video, part C. So we're told the event C has probability of C occurring at being 0.2. We're told the events A and C are mutually exclusive, and the events B and C are independent. And we're asked to find the probability of B intersection C. So the most important thing here is that B and C are independent. We already know the probability of B. So the probability of B is 0.45. The probability of C is 0.20. So if we want the probability of B intersection C, we just know, or we just use the formula that we know, which tells us the probability of B times the probability of C is equal to the intersection of those two events, so B intersection C. And that's what we're looking for here. So all I need to do to find my answer for C is just multiply these two probabilities together. So therefore 0.45 times 0.20. And if we evaluate this on our calculator, I'll just find 20% of 0.45. What you get here is 0.09. Okay, so this was for part C there. Okay, and you should get 0.09. And that brings us to the end of this video on probability. So hopefully you found this helpful. If you do notice any issues that I've made throughout the video, that's always a possibility. Again, like always, please leave a comment down below. And if there's anything that's unclear, again, just leave a comment down below. Cheers.